Hi everyone. So in lesson 5.1 of calculus, we were talking about how to find the areas between two curves. And I noticed that this was somewhat challenging. So I picked five of the homework questions to practice this with you. So in number 3, they actually gave you this graph in your book. And this red line here is the function y squared minus 1, and it was labeled for you in the book. The blue line here is the function x equals the square root of y. They shaded in between, and they told you that this was 1 up here. They told you that this green line was y equals 1. So when you're doing this, notice these were given in terms of y. So we're looking at the y values. That means we're looking the right function minus the left function. Okay, so the right function minus the left function in our integral. That's how I got this. And then for the limits of integration, we look for the lowest y value, which is 0, and the highest y value, which is 1. And so lowest to highest is 0 to 1. So this is the integral you would get from this. And yes, you could write the square root of y as y to the 1/2. Okay, let's look at number 4 as well. In number 4, they gave you a graph. They showed you this blue line here, which is x equals y squared minus 4y, and they had it labeled. And they showed you this green line here, which was x equals 2y minus y squared. And they shaded in between it, and they wanted this area. So again, we're working in terms of y. So our right function is the green function. That would be the 2y minus y squared. And the left function is the blue function, y squared minus 4y. So it's going to be right minus left. So 2y minus y squared minus y squared minus 4y. And watch out for those parentheses, because if you don't put them correctly, you could simplify incorrectly and accidentally have your y squareds cancel out, when really you should have negative 2y squared. Now for the limits of integration, notice we're taking the y values of the two places where this crosses. It crosses at 0, 0, and it crosses at negative 3, 3. So the y values for those are 0 and positive 3. So 0 is going to be your lower bound in your integral, and positive 3 is going to be your upper bound in your integral. Let's look at number 5 as well. In number 5, they didn't actually give you the graph. You have to graph it. And I know when I assigned your homework, I said you don't have to show the graphs, but I did want you to actually graph them, because otherwise you can't tell what's going on. Notice when you graph it, the blue function is on top and the red function is underneath. So the blue function is the 9 minus x squared function, and the red function is the x plus 1. So it's going to be 9 minus x squared minus x plus 1. Now, as far as your limits of integration, they gave us x equals negative 1 and x equals 2 to say that they wanted this green shaded area in between the graphs. Okay, so for this, we're going to use negative 1 as the lower bound and 2 as the upper bound, because they wanted it from negative 1 to 2 on your x values, and then it's blue minus red. So this is the integral you come up with. Okay, let's look at number 6 next. In number 6, again, they didn't give you the graph. You had to graph it yourself. So I graphed y equals sine x, y equals x, and then they also gave us x equals pi over 2 and x equals pi. Now, the pi over 2 and the pi are going to deal with our integral, our limits of integration. But looking at this, the blue function is always above the red function in this section of our graph where they've limited us to. So it's blue minus red. So it's going to be x minus sine x, because it's upper minus lower. Then for your limits of integration, pi over 2 is less than pi. So pi over 2 is going to be the lower limit, and pi is going to be the upper limit. Now we have one more to do, and this one's a special one. I picked this one because the graphs cross in the area that we're interested in. In number 23, they gave us cosine x and sine 2x from 0 to pi over 2. Now, 0 is here, pi over 2 is here, and notice the red function's above right here, but then the blue function is above right here. So we need to divide this up into two separate integrals with this point as our dividing line. So, for the first integral, the red function is above. That's cosine x. And the blue is below. That's sine 2x. Okay. Did it go on the other page? Yes, there it is. Okay. So, let me just fix this. Oops, it's not going to let me. Okay. No problem. Okay, so we have 0 to pi over 6 cosine x minus sine 2x dx. So that's the first part, from here to the pi over 6 point. Then the blue function's on top and the red function's underneath. So it's going to be sine 2x minus cosine x. And this is from pi over 6 all the way up to pi over 2. Okay, so that's how I got my integral for that. And then you would calculate these separately. You do this integral first, then you do this integral. Okay, so that's it for this video. Please let me know if you have any questions or if you need any more help with this.